Good morning, everyone. My name is Sidi Mohamed Sall. Today, I'm going to talk about my project about deadlock redetection and evidence in modern operating system. So let's start. For the first part, we're going to talk about the critical issues of deadlocks. Um, the deadlock deadlock like is when two or more processes are permanently blocked, each waiting for a resource held by another. It is an essential operating system responsibility due to heavy reliance or multitasking and shared resource without proper handling. Freak locks freeze application and reduce system responsiveness. The diagram illustrates the core problem: a circular weight dependency here, as you can see here for the diagram. And after we're gonna talk about the four necessary conditions for deadlocks. Um, as you can see here, um, a resource cannot be avoided by taken away. A closed chain of processes exists where each where each wait for the next. As you can see that diagram from here too. And after there is the modeling resource allocation. So here there is OGS. This one is used for the resource allocation graph area to model relation between process and resource. And after there is dependencies. This is a cycle in either graph is like an indicator of possible deadlock. Like these models are critical for design, detection, and avoidance algorithms. So for the classical deadlock handling technique, um, for the third key point, there is prevention eliminate the possibility of deadlock by ensuring at least one Kaufman condition can never hold common method, and for a strict global ordering of resource acquisition to eliminate circular weight trade-off, reduce concurrency, and lead to inferencing. So here there is a Bankel algorithm. This is one key of evidence method. The most influent evidence is Banker algorithm. It simulates execution using resource allocation matrix and maximum resource demand. Like a request, demand is a request. A request is approved only if the system can guarantee that every process will complete eventually trade-off. Here for the modern approach, detection and recovery. Um, Here, the recovery involved terminating process, preempting risks or relaying back operation. Practical, for example, Linux use locks dependency tracking and Windows corporate detection within its driver framework. For comparative analysis of deadlock strategy here, from here as you can see from the diagram here, they that one they chose they chose always a trade-off between safety, overhead, and implementation complexity. So for the conclusion, there is one thing we should know: no single technique is universally optimal. You can use a approach applying different strategy to different subsystem and or and this trade-off is essential of for designing robust resource management and policies. So thank you for your listening.